The question today is we are given a linked list and we have to sort it. So I'm thinking we should do it using merge sort because that will be easier and quicker because merge sort does the work in n log n time. So what we'll do is we'll take this linked list and what we are going to do is we'll divide them in two halves and we'll keep dividing them in two halves till the time we get one linked list, that is till the time we'll get 4, 2, 1 and 3 separately, and then we'll check, we'll compare them and then we'll merge them. Basically it's a simple merge sort algorithm. Let's just start writing it and then we can then I can explain it from the code itself. So the first thing that we have to do is we need to break the linked list. So how we'll do that is we need to find the middle element of the linked list. So for finding middle element, what we can do is we can use the longest fast and slow pointer method. So I'll do that. I'll take a fast pointer and I'll take a slow pointer, both pointing to head nodes. And while I have my fast and I have my fast next, I want to keep traversing the linked list. So fast will be equal to fast next, and slow will be equal to slow next. Okay, we also want to check if my head is not there, is equal to null pointer, or if head next is equal to null pointer, then I'll simply return head because that is the base condition, and if the linked list is empty, I'll just return the head. Okay, next what I want to do is we'll be using recursion. So once I'm done dividing this given linked list, I want to dividing it, so I'll use the recursion. What I'll do is, let's say I'll take a list node for right side, which will equal to sort left and let's start left side. So for left side, this will start from head, right? Okay, and for list node star, it will be right side, which is equal to sort list. For right side, basically what I'm trying to do is the two halves that the linked list will be divided will be something like head, and the end will be slow pointer, and the second half will be slow next to my fast pointer. Okay, so I have given the starting head to the left side and I want to give slow next for the right side. So slow next. Okay, also I do want to do one thing, which is my slow. I want to break it, so I want to do something like slow next over here. Slow next should be equal to null pointer. So since it's initially it's joined like this, so slow is pointing to slow's next, but since I want to break it, I want to do something like slow next to be equal to null pointer. This is what I'm doing. So this will be my first partition and this will be my second partition. Okay, so this is done. Next I want to return so at this point we are done with our partition. We want to merge it, so I'll use another function called merge and I'll give it parameters called left side and right side because we want to merge both the left and right side together. Okay. Alright, so now let's go ahead and write merge function. Okay, I want to take this as my return type, so and then merge, it will be list node star L and then list node star RLGHT, name it left and right. Okay, so this is my merge function. So yeah, so the first thing I want to do is make a new fresh linked list, which I can do using list node star, let's call it new node, and it will be initialized with the list node, let's just initialize it with 0. Okay, next what I want to do is I will be creating a pointer which will point to this new node, and we'll using that pointer we'll be adding other values, other nodes to my new node. Alright, so I'll say I'll take list node star let's just call it temp, and this will, my temp will point to new node. Okay, alright, now we'll be looking at this left and right, which is my left side and right side. Okay, sorry, over here I need to change it. So if I have both left and right sides, like as long as I have my left side and I have my right side, what I want to do is I'll check if left value is more than my right value, so I will, so my right value is, which is right side's value, is less than left side value, and we want to we'll be doing ascending order. So in the new node, in temp next will be equal to my right next, will be equal to my right. Yeah, and next thing what I want to do is I will be moving ahead in right side, so right will be equal to right next. Okay, again I'll check if this is not the case, then my right side will, so temp next will be equal to left, and my left will be incremented by left next. Okay, also I will be incrementing the temp, so So I was saying I will be incrementing my temp because if my left is more, temp will add right value. If my right is more, temp will add left value, and then it needs to move ahead. So temp will be equal to temp next. Yeah. Okay. So once we are done with this, we will be checking if I still have something left in my right side or left side. So if my left is there, all I'm going to do is my temp will be equal to, if left is there, so it will be equal to left temp next will be equal to my left, else temp next will be equal to right. So if it will only have left or right, because over here if one of the condition goes false, so if suppose left goes false, my right will still be there, so it will come over here and it will just add the right part to temp. Okay, so by this time we have added we have merged both left and right part in a new node, which is this, using this temp pointer. The last thing which I want to do is I will be returning the new node. So I'll just say return new node, and this should work. Let's try to submit it. Head equals to something is wrong. If okay, I will be returning, sorry, I will be returning next because yes, it's already added and I want to do the next. Okay, I mean, I'm getting a runtime error. I guess something is wrong over here. Okay, so what I'm doing is I'm pointing slow next as null pointer, and then I'm taking slow next, so it won't be pointing to anything. So this should be before this. Okay. Also, I think this should work. If my left side goes, so this should be above, or no, this should be here. Okay, so if this is the case, then for left side this will run to through entire linked list, so this will come over here because I will start from right side, will start from slow next to the last pointer, and then I'm making this as null pointer. So left side will start from head and will go to this slow. Okay. Yeah, I was thinking about this as well, if I should start from head, sorry, next and next. What if it's not, and yeah, it will work. Okay, it does. Okay, so that's it. That is the solution. It was, I use simple merge and sort. They say we can do it in O1 memory and ON login time, but since I'm using recursion, it's not O1 time, it's basically using ON time, but I feel like for interviews this will be enough to show. So yeah, thank you.